Welcome to another Explainer. Today, we are cracking open the examiner's blueprint for mastering series and parallel circuits. We're stripping away the confusion, tossing out the noise, and simplifying the complex. Now picture two students taking their Cambridge physics exam. Let's call them Alex and Sam. Alex overloads every answer with raw physics facts, but completely forgets to analyze anything. Sam? Sam just rushes through and completely misses the command word requirements. Both of them lose easy marks. If you're studying for your physics exams across syllabus codes like 0625, 0651, 0652, 5054, or 9702, and you want to see exactly how top marks are won and lost using the principles of circuits, you are in exactly the right place. Let's jump right in.
Here is our game plan for today. We'll cover the 15% challenge, dive into core circuit principles, break down the method mark strategy, look at execution and evaluation, and wrap up with some critical examiner warnings you absolutely cannot ignore. All right, Section 1, the 15% challenge. Let's talk about the real stakes here and why mastering this specific topic is basically your golden ticket. Concepts surrounding series and parallel circuits account for approximately 15% of the total marks in many standard Cambridge physics examinations. 15%. Let that sink in for a second. A huge, massive chunk of your entire grade hinges on your ability to confidently manipulate current, electromotive force, and resistance. If you master this, you're building an incredible safety net for your final grade. This isn't just a minor subtopic to gloss over. This is quite literally a foundational pillar of the examiner's blueprint. So despite this huge weight, principal examiners constantly ask, why do candidates struggle so much when these fundamental rules are placed into unfamiliar contexts? Well, it goes back to our friends Alex and Sam. Students memorize the standard textbook diagrams, but the very second an examiner introduces a circuit with an unusual, weird shape or embeds it into a real-world scenario, absolute panic sets in. Why? Because they've learned the shapes, not the underlying system. The reason students fail here is a lack of what the examiners call systematic processing. They see a new diagram and they just guess, rather than applying the immutable laws of physics step by step. We're going to fix that right now. Moving into Section 2, Core Circuit Principles. We need to simplify the complex and lock down the absolute core principles the syllabus demands you know. This direct comparison perfectly illustrates the heart of the matter. You need to instantly recall these foundational rules of current, resistance, and electromotive force. On the left, in a series circuit, you've got to remember that the current is the exact same at every single point. It only has one path to flow, right? Furthermore, the combined electromotive force, or EMF, of sources in series just adds up, exactly like the combined resistance of resistors in series. It's totally cumulative. But look at the right side, parallel circuits. This right here is where examiners love to set traps for you. In a parallel circuit, the current from the source is larger than the current in each individual branch because it splits. And here is the absolute most tested, counterintuitive fact. The combined resistance in parallel is actually less than either individual resistor. Why? Because adding more parallel branches gives the current more pathways to flow, which reduces the overall opposition. This is exactly why there are massive advantages to using parallel lamps in lighting circuits. If one lamp blows, the others stay on because they have independent pathways to the power source, and they all receive the full source voltage. Have these rules hardwired into your brain, and no weird diagram can ever trick you. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, examiners aren't just testing your memory, they are targeting distinct cognitive domains spanning from basic knowledge all the way up to complex cross-topic integration. They use very specific command words to target these domains. For example, when a prompt says state, they are testing your pure knowledge. When it says calculate, they are testing application. When it says explain, they are demanding analysis. Top students structure their physics answers using frameworks like PEEL, that's point, evidence, explanation, link. Applying PEEL ensures your answers are structured, logical, and hit every single assessment objective required. Here's a major examiner alert for you. Candidates consistently confuse key terminology. You must always define your terms clearly before using them in extended responses. For instance, when you're talking about the combined EMF of sources in series, please don't just say total voltage. Use the precise professional terminology, combined electromotive force. By simply swapping out casual, everyday words for precise scientific terminology, you instantly transform a flawed, ambiguous answer into a top mark response. Words really matter in physics. They're your tools.
Let's roll into section 3, the method mark strategy. This is all about earning points for your process, not just your final answer. The method mark strategy relies entirely on this standardized sequence you see on the screen. It ensures you get awarded marks just for demonstrating the correct procedural framework. Imagine turning a page of red pen marks into beautiful green check marks. First, identify the key elements. Which components are in series? Which are parallel? Second, apply the relevant principles, like recognizing where current stays the same and where it splits. Third, execute your analysis with clear working. Write down your formula before you plug in a single number. Examiners actually award method marks for the correct formula alone. Fourth, verify your results. If your total parallel resistance comes out higher than the smallest resistor, you know you made a math error. Finally, present your answer in an appropriate format with the correct unit, ohms, amps, volts, whatever it is. By writing down steps 2 and 3 clearly, even if you mess up the math later, the examiner rewards your systematic processing.
Section 4, Execution and Evaluation. This is about building that top-scoring mindset. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into it. Top-scoring candidates tackle complex circuit problems using this exact deconstruct, solve, evaluate methodology. Let's do a quick interactive challenge. I'm going to give you a flawed physics paragraph, and I want you to find the flaw. Ready? The circuit has 2 lamps in parallel. The total resistance is the sum of both lamps. Did you catch the flaw? Based on our core principles, combined resistance in parallel is actually less than either individual resistor. So the total resistance would decrease, not increase. This is exactly what the deconstruct, solve, evaluate process prevents. Step 4, check for reasonableness, is basically your built-in lie detector. If your parallel circuit calculation yields a higher overall resistance, your reasonableness check should immediately flag it as incorrect based on foundational theory. Take a look at this quote straight from a principal examiner report. Integrating your circuit knowledge with other syllabus areas is literally the secret to unlocking maximum marks. Examiners don't just want isolated facts. They want to see if you can consider how the current in a series circuit relates to thermal energy transfer, or how the advantages of parallel lamps connect to concepts of electrical power and efficiency. When you can logically link the drop in combined resistance in a parallel circuit to an increase in power dissipation, you are operating at the highest possible level. You're showing the examiner you truly understand how all of physics is connected. Evaluating evidence requires you to justify your decisions and identify limitations. Let's frame this as a speed writing challenge. If an exam asks you to justify why a house is wired in parallel rather than series, you need to quickly formulate a structured PLE response. Your point: parallel circuits allow independent operation. Your evidence: if one branch breaks, current still flows in the others. Your explanation: parallel circuits provide multiple paths for the current, and each branch receives the full source electromotive force. Finally, your link: parallel wiring is advantageous for household lighting because turning off the kitchen light doesn't plunge the entire house into darkness. Boom, that is exactly how you justify decisions with evidence and nail those evaluative thinking requirements. Finally, Section 5, Critical Examiner Warnings. Let's talk about avoiding those common pitfalls that drag your grade down. Even with perfect physics knowledge, you can lose super easy marks. Here are the top 3 mistakes cited in examiner reports that consistently drain points from otherwise capable students like our hypothetical friend Alex. Number 1, forgetting proper format. This means missing units. A number without a unit in physics is just a meaningless scratch on a page. Is it 5 amps, 5 volts, 5 ohms? Tell us. Number 2, forgetting to check presentation. If the examiner cannot logically follow your scribbled steps, they cannot award you the method mark. And number 3, providing answers not specific to the context given. If the question asks about the advantages of parallel lamps in a car's lighting circuit, don't write a generic answer about domestic household wiring. Apply your core principles to the specific vehicle context they provided. To make sure you never forget the advantages of parallel lamps or combined resistance rules, try creating a personal mnemonic using the first letters of key terms. For example, for series circuits where current is the same but voltage adds up, you might use something punchy like same current, add voltage, SCAV. Find a memory hook that actually works for your brain.
The cognitive load during a high-stakes exam is absolutely immense, and these little memory hacks bypass the panic response, letting you instantly recall crucial facts, like how in a parallel circuit, the current from the source is larger than each branch, while the combined resistance is less.
Remember, presentation is an explicit professional skill being tested here, so strict adherence to formatting conventions is totally non-negotiable. Use proper headings, correct terminology, appropriate formats, and clear annotation. Think of it as the ultimate physics success blueprint. To guarantee top marks, follow these 3 rules. 1. Command word decoding, know exactly what the prompt is asking. 2. Strict Peel framework application, structure your answers logically. And 3. Time management. Don't spend 10 minutes on a 2-mark question only to rush a 6-mark evaluation. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
As you wrap up your studies, I want you to ask yourself, is your systematic processing strong enough to decode the unexpected? Have you mastered the rules well enough to accurately apply them to an entirely unseen circuit diagram? Think about whether you can look at a bizarrely drawn combination of resistors and calmly apply the immutable laws that series resistance adds up and parallel resistance drops. Master the blueprint, trust your process, and you will absolutely transform those complex diagrams into clear, confident understanding. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.